Assalamualaikum. So today we will discuss about Bohr's law in chapter 6, Physics 210. My name is Siti Syuhada binti Muhammad Tukri from group RAS 1202E. My student ID is 2020824412. So here is what we will discuss today. Number 1. Definition of Bohr's law. So, what is the Bohr's law? Bohr's law is a relationship between a gas compression and expansion at constant temperature. So, note here, the temperature is constant. We will write this as PV equal to K. K is a constant while P is pressure, V is the volume. When a gas is compressed, it occupies less space. So the smaller the volume, the higher the pressure. So according to Bohr's law, pressure is inversely proportional to the volume. This is the graph of Bohr's law. Second is Bohr's law formula. We know that the pressure is inversely proportional to the volume. This is how we write Bohr's law formula. This is an example of Bohr's law. So for number 3 is a real life example of Bohr's law. So first is filling white tires with air. So when you inflate a tire, the gas molecule will compress and pack closer together. As a result, the gas pressure rises and begins to push against the tire's walls. So when we touch the tires, you may feel tight and more pressure in the tire. Second is soda bottle. So the soda bottle is frequently compressed with gas to get carbon dioxide gas into the liquid. The gas is contained to a tiny space and pushed against the bottle's walls, while the container is closed, making it difficult to crush. So, removing the cap expands the accessible volume, allows some of the gas to escape. Its pressure also drops at same moment. So, in our daily life, breathing is also a Bohr's law. Inhaling and exhaling increase and decrease the volume of our chest cavity, respectively. This causes low and high pressure in our lungs, which cause air to be sucked into and expelled from our lungs. So let's solve the question together. So a deep sea diver is working at depth where the pressure is 3.0 atmosphere. He is breathing out air bubbles. The volume of each bubble is 2 milliliters. At the surface, the pressure is 1 atmosphere. What is the volume of each bubble when it reaches the surface? So this is how we solve it. So we know that the initial pressure is 3 atmosphere. The initial volume is 2 milliliters. The final pressure is 1.0 atmosphere. But we don't know the final volume. So by using the Bohr's law formula, P1V1 equal to P2V2, we write here 3.0 atmosphere times 2 milliliter equal to 1.0 atmosphere times V2, which is we don't know the final volume. So we will get V2, which is final volume equal to 6 milliliter. So lastly, this is my reference. Thank you. I hope everyone can learn something from my presentation.
Hello you all, my name is Siti Munirah binti Yusuf and my ID number is 2020464682.
So now, I will explain to you about the Charles law. First thing first, you must know about the definition of the Charles law, which is the volume of a given amount of gas is directly proportional to the absolute temperature, which is in Kelvin, when the pressure is kept constant. That means the volume of a gas is equal to constant value of multiplied by its temperature as measured in the Kelvin scale, which is 0 Kelvin equal to negative 273.15 degrees Celsius. Why we use Kelvin scale? That was because, according to the physical meaning of temperature, the temperature of a gas is determined by the chaotic movement of its particles. The colder the gas, the slower the particles. At the 0 Kelvin, which is negative 273.15 degrees Celsius, the particles stop moving and all disorder disappears. Thus, nothing can be colder than absolute zero in the Kelvin scale. Next, we will see about the formula in the Charles law. The formula is V1 over T1 equal to V2 over T2, which is V is equal to the volume of the gas and T is equal to temperature. You can see below when the colder, the volume in the balloon is small, but when the hotter, the volume in the balloon is larger. Now we will learn about the graph in the Charles law. You can see although there are different pressure is acting, the volume is always directly proportional to the temperature, and you can also see in the picture when the heat is applied, which is that the temperature is increased, the volume is also increased. So I will give you example of Charles law in real life. First one is hot air balloon. You may have been curious, right, about how a hot air balloon works. Temperature and volume are directly proportional to each other. According to Charles' law, when you heat a gas, it expands. As the gas expands, the density of the gas decreases and the balloon rises into the air. Warm air is less denser than the cold air, which means it's lighter. Warm air also has a lower mass per unit volume. Example is deodorant spray bottle. If you ever read the instruction on a deodorant bottle, you have probably noticed the caution warning advising that the bottle should be kept away from direct sunlight and extreme heat. Have you ever wondered why? Charles' law hold the answer. High temperature cause the air molecule in the bottle to expand and causing the deodorant bottle to burst. So, if you use the deodorant spray bottle, please be safe.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Osman and my student number is 2020869128. So, we will continue our presentation with Gay-Lussac law or pressure law. Firstly is the definition. For a fixed mass of gas at a constant volume, the pressure is directly proportional to the absolute temperature. Gay-Lussac law, a Montan's law or the pressure law, was found by Joseph Louis Gay-Lussac in 1808. The general equation of pressure law is pressure is directly proportional to temperature. P over T equals to constant. P1 over T1 equal to P2 over T2. Next, we will take a look at graph of Gay-Lussac law or pressure law. As we can see, the graph shows that pressure is directly proportional to the temperature. There are many applications of Gay-Lussac law or pressure law in our real life. The first one is aerosol can. The second is the tire pressure. The third one is pressure cooker. And lastly is the water heater. So I'm gonna tell more about the application in aerosol can. When you press down on the button, the valve opens and reduces the pressure at the top of the can. The pressurized gas then tries to escape the can by going out the tube and out the nozzle. But since the liquid is in the way, it pushes that out with it. Next is pressure cooker. Gay-Lussac's law says that as the cooker heats up, the water turns to vapor that cannot escape, building pressure from within. The pressure and temperature continue to build until it exceeds the normal boiling point of water at 212 degrees Fahrenheit. Lastly is the application of water heater. When a person switches on the home water heater, the filament inside the water heater gets heated up. As a consequence, water inside the electric water heater also gets heated up to its threshold temperature. The hot water generated is released through the outlet nozzle.
Hi, I am Siti Nur Alia Masara binti Rosidi. My student number is 2020815186. I am going to present about the ideal gas law. The three gas laws, that is Charles, Boyle's, and pressure law, can be combined into one equation which is called the ideal gas law. The ideal gas law is the gas law that includes all four variables: pressure, volume, temperature, and number of moles. The complete equation for ideal gas law is PV equal to nRT. When the pressure, temperature, and volume of a contained gas are known, you can use the ideal gas law equation to calculate the number of mole of the gas. Pressure is force exerted over an area. It is measured in millimeters of mercury, kilopascals, and atmospheres. 1 atmosphere is equivalent to 760 millimeters of mercury, is equivalent to 101.3 kilopascals. Volume is how much space something takes up. It is measured in liters. 1 liter is equivalent to 1000 milliliters, is equivalent to 1000 centimeters cubed. Moles is the number of gas particles. It is measured in mole. 1 mole occupies 22.4 liters. Next is gas constant R. It is a universal constant required to make the ideal gas work. Its value depends on what units of pressure you are using. If you are using ATM, R is equal to 0.0821. If you are using kilopascals, R is equal to 8.315. If you are using millimeter of mercury, R is 62.4. Temperature is the average kinetic energy of particles. In gas law, temperature is always measured in Kelvin, and these are the temperature conversion scale. Standard temperature and pressure, STP. The volume of a gas varies with a change in temperature or a change in pressure. Due to these variations, the volume of a gas is usually measured at STP, where at STP, temperature is 273 Kelvin, pressure is 1 atmosphere is equivalent to 1.013 times 10 power of 5 pascals, equivalent to 101.3 kilopascals. 1 mole STP gas has a volume 22.4 liters. Lastly, let's try to solve a question about the ideal gas law. The question is, if 4.65 moles of an ideal gas has a pressure of 4.37 atmospheres and a volume of 91.49 liters, what is the temperature of the sample in degrees Celsius? Okay, first step, we need to write down the equation of the ideal gas law, PV equal to nRT. Then we adjust the formula to make sure T as a matter of the equation, T equal PV over nR. Then we write down all the informations given in the questions. N equal to 4.65 moles, P is 4.37 atmospheres, V is 91.49 liters, T is the unknown we're going to find, R is 0.0821 liter.atm per mole.k. Then we substitute all the values given in the formula and we will get the answer is 1047.27 Kelvin. But the question asks to give the answer in degrees Celsius, so we need to use this temperature conversion scale to convert from Kelvin to degrees Celsius. 1047.27 minus 273.15, and we will get the final answer is 774.12 degrees Celsius. That's all from me. Thank you.